Hashing, a process of taking data of any arbitrary size and mapping it to a fixed size value. The hash function is pure, meaning it will always produce the same output given the same input, and the value produced is really hard to reverse, making it perfect for things like securing passwords on a database, or even as data structures called a hash map, which languages like JavaScript or Python heavily rely on for their objects. Hash function use cases are endless, which is why every developer should at least know how to use them. Today we'll implement a simple password hashing example using nodejs. If you've ever stored user information on a database, you might know that using plain text for passwords is probably not a good idea, since when you have a data leak, a hacker can simply log into any user account they like, unless you hash all of your passwords beforehand and then check users' password against the hash rather than plain text. Let me show you what this might look like in code. We'll start out by importing the create hash method from the inbuilt crypto library. Then we can define some user input. In this case, I created some static variables, but you'd probably collect these via forms or something. We can now call create hash with the function that we want to hash with inside of it. I'll demonstrate this using SHA-256, which produces a 256 byte output and is relatively fast. There are some unsecure hashes out there like MD5, which as computers got faster, it got broken. This gets to show that hashing functions are constantly evolving as our hardware gets better, and with the introduction of quantum computing, SHA-256 might be replaced very soon by some sort of an improvement. We can now chain the function update with the value that we want to hash, which in this case is the password, and then call digest to produce the hash passing in the encoding that we want to use. I'll be using the hex encoding, but you might see base 64 out there too. When we log this out to the console, you can see that we get the exact same value every time we call this function. So after this, you'd save this hash in a database and then run the hash function again to check if the user inputted the correct password. This does provide a lot of protection for the user, but if they use a commonly used password such as password1234, then this can still easily be cracked by the use of rainbow tables, which are just big databases of values with their associated hash. We can actually prevent this by using something called a salt. A salt is just a random value that is added to the password before it's hashed, making it basically impossible to guess. To do this, we'll import the script sync and random bytes methods from Node Crypto. We use the random bytes method to create a 16-byte salt that is used inside of the script sync method to generate the final hash. The salt and the hash can then be stored in a database and the function repeated when the user is trying to log in. This was hashing as fast as possible. If you enjoyed the video, please like and subscribe, and I'll see you in the next one.